My name is Jamie Stark. I look after voice interoperability and networking for Microsoft Lync. I'm joined by Pascal Menzies. Pascal looks after all things networking for Microsoft Lync and Skype, and we're here to talk about software-defined networking. So this is your software-defined networking. It's Network 300. I always start off all of my presentations with the same message. Please, 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 take an opportunity to fill out your evaluations. I'm going to leave the clicker be now. Please take an opportunity and fill out your evals. It really does help us. In real time at the show, we look to adjust the content. We look to adjust. And I swear to the Lord, I'm not touching the damn thing. My hand's in my pocket. My other one's right here. Anyway, perhaps the clicker is malfunctioning. First session of the day, we get to work out some fun kinks. One of the great pleasures I've had in the last couple months is helping to set up a lot of the content here at the conference. So one of the things that we made a pretty early bet on was talking a lot about software-defined networks. And so we actually have 4 sessions here at the show where we're going through different aspects of the work that we've been doing. This is our overview session. So this is while 300 level, and we're going to be getting into some technical topics. This is meant to be a survey of all the different things that we're doing with SDN, and we're going to talk a little bit about the APIs and some of the other things that are going on. And then from here, we actually have 3 deep dive sessions that are happening. One on diagnostics, one on Quaz, and one specifically focused on Wi-Fi. And each of those 3 deep dive sessions are also repeated as well. So I know here at the conference we have 17 sessions generally happening simultaneously, and so that's a fair amount. We understand. So if you're not able to catch the first iteration of a particular session because you've already got something else in your agenda, please don't hesitate to hit up the repeats as well. And as you heard me say earlier, everything that we're doing here at the conference is being recorded and will be posted up to my Lync for your asynchronous consumption. In addition to that, those 3 sessions that we're doing, diagnostics, quality of service, and Wi-Fi, we're actually doing in conjunction with our partners. So our partners are going to be up on stage with us talking about how they're actually implementing their solutions using the SDN capabilities that we're building into Lync Server. In addition to that, they have a lot of their own breakout sessions as well. So Aruba Networks from a Wi-Fi perspective, HP, and Nectar, all sponsoring here at the show. Aruba and HP have separate breakout sessions within the solutions track. And then we're all getting together Wednesday at noon in the Microsoft Pavilion. That's the big kind of demo area that we have set up in the center of the expo hall to have just an open conversation about this stuff. So if there's things that you hear in any of the SDN sessions that strike you as odd, or you want to go into more additional depth, or whatever the case may be, don't hesitate to hit us up at the Pavilion Wednesday at 12. So what we're going to do is I'm going to kind of take folks through a little bit of a primer on SDN. This is a topic that, just from a Lync and UC perspective, we're just starting to talk about with some regularity. And so I wanted to bring everybody kind of up to speed on what's going on in the industry, where this technology came from, and how it's kind of moving into the enterprise. And then I'm going to talk a little bit more specifically about Lync and how we think about packet networks from an enterprise networking perspective, and kind of compare and contrast a little bit of how we've traditionally been doing things and how we think some of the opportunities can open up with respect to SDN. And then Pascal is going to be able to come up, and he's going to take us through some depth around the API. And Pascal is also deeply involved in a lot of our industry standards activities. So there's a bunch of standards bodies that are actively working this topic that Pascal's been engaged with. He's going to be able to kind of take us through that. And then finally, we are very, very blessed to have Jim Burton as well, who's going to be able to come up and kind of give us a perspective from an independent analyst point of view. And so that's what we're going to be doing today. Does that all sound like something that's vaguely interesting to you all? Yay! Excellent. Very good. I appreciate the little bit of feedback there. Thank you so much. So a little bit of start off on the brief primer around SDN. I have a buddy who works in IT for a fairly significantly sized media company, and one of their IT operations is based out of Seattle, and they've had a data center there for like a decade. To the point where when they moved into the building, they were the ones installing the racks in the data center, right? Like, they've been there for so long, they know all the little kind of goofy things down to the physical wiring of the shop, and they realized that they were starting to expand outside of what this particular data center could provide, and they were going to need to move. And I was out having beers with him a couple weeks before the conference, and he was just telling me the story of this pain that was going on where, it was very, very heavily virtualized infrastructure. So they were running everything within VMs, but even still, when they would go in and try to move their VMs from their existing data center and spin them up in their new data center, the pain that they were having to go through to do that. And literally, it was taking them, somewhere on the order of 3 or 4 tries. Of course, the try is happening, off hours, from 11 o'clock at night to 2 in the morning, where they would move a bunch of their services over, and then they would try to, change over DNS, and they would try to change over their VLANs, and they think that they would get everything set up, and then they would start to do their testing, and they'd realize, oh crap, nope, that piece wasn't picked up by that switch, or oh, that piece wasn't picked up by DNS, and oh no, we've got to roll everything back. And for every service, they would go and they would plan this out, and they would do all of that, really, really detailed planning to do this. But consistently, it would take multiple tries for them to move these capabilities and these services over from their existing facility over to this new facility, and it was just ridiculously frustrating. And as I was talking to him, this image kind of came into mind of the fact that while he had a very kind of flexible environment from kind of a software and applications perspective, where everything was really highly virtualized, and they front-ended everything within F5, and they had this kind of great application level infrastructure, it was really stymied by their network infrastructure, and that their actual topology was really limiting what they could do as they were looking to have some flexibility across their data centers. And so, here in this example, if I want to add a new service or a new VM, like, what are all the VLAN tags that I've got to go and think about across my top of rack switches? And then if I go and I'm adding, additional services, then I've got to think about not just top of rack, but also my aggregation layer as well. This is just, kind of from a VLAN perspective, there's just a bunch of pieces here that you've got to look at and you've got to think through. And fundamentally, we think that, in the industry, I think broadly has come to this conclusion, that there's huge opportunities here to really be more agile, be more flexible in our IT operations generally, by kind of breaking apart our application workloads from our networking workloads, and to think about them separately and to have some plasticity there. And this is really where fundamentally SDN came from. And so just a little bit of a history lesson here on what was going on. It was started kind of back in 2008, 2009, where a bunch of researchers over in the Silicon Valley, primarily Stanford and Berkeley, they're playing around with new network architectures and new protocols. But when they were playing around with them, they wanted to be able to actually have them running on a real live network, which, if you want to play around with experimental protocols in a real live network, that could be kind of dangerous, right? Because you could, potentially, blow stuff up. And blowing up the Stanford network probably wouldn't be something that would be, very good for the researchers' tenure and so forth. And so they wanted to think about a way that they could be able to overlay new networking protocols and do some of these experiments without messing with kind of the underlying fabric. And that's fundamentally where the standard called OpenFlow came from. And what OpenFlow is designed to do is to provide a communications path between network intelligence and the actual components that are, the actual physical hardware components that are running the network. And very, very early on, in some of the, really kind of early, proto instances of software-defined networking, this was picked up incredibly fast by a lot of the cloud-scale data centers. So if you think about the Amazons of the world and the Facebooks of the world and the Azures of the world, very, very quickly, everyone that was having to think about running dynamic infrastructure as a service and having to have just massive sets of services realized that, wow, if we could think about networking in the same way that we think about software, this could be tremendously powerful. Now, the other thing that actually ended up happening was we could also run some of that underlying infrastructure. You could start to run that on commodity hardware. And so when you're thinking about something the scale of a Google, or again, the scale of an Amazon or the scale of an Azure, being able to think about your network running commodity hardware was tremendously powerful, just purely from a TCO perspective, right? Purely from the amount of dollars that you've got to spend on this stuff. And so from that, this concept of software-defined networking came up. And I literally pulled this definition straight from the PDF reference there at the bottom from opennetworking.org. And it really just, it has kind of three key components. First, we want to think about decoupling the control of the network from the actual data plane, from the actual plane that the data is flowing through our network infrastructure. And then I want to take all of that control and I want to centralize that, and I want to put policy around it, and I want to be able to have that existing in software. And what that does is it fundamentally provides an abstraction layer between my applications kind of running up on top and my core infrastructure running down below. And so this is kind of a view of what that looks like, from an OpenFlow perspective. So if we think about, the kind of traditional way to think about network switches and network infrastructure, where I have the control plane and the data plane running physically within the same box, what OpenFlow fundamentally does is it disaggregates that, and it pulls that control plane and centralizes that in a piece of software that we call a controller. And then OpenFlow is the protocol that operates between that controller and then an agent, a really lightweight agent that's running on the network switch, that's running on the network infrastructure. And then that lightweight agent is giving the data plane all the flow information of what to do as packets come in. And if a packet comes in and hits that switch that doesn't match that flow table, then it'll go and it'll send a message up to the controller with that packet and say, hey, what should I do with this now? And the controller can come back and say, oh, great, add a new rule, handle the packet this way. And so that way, all of the intelligence that happens within the network, again, can be centralized and can have policy on it from this controller platform. As I said, big cloud-scale data centers have been picking this up for the last few years. This is Microsoft's view of how we think about kind of our cloud, right? So when you think about Hotmail and Azure and Office 365 and all of the gigantic services that we're running up in the cloud, and Bing and Skype and everything else, this is fundamentally our architecture. All right, this slide comes from the Azure guys. And what we fundamentally need is a way to have our storage and our MIPS and our processing capacity and our network services all to be dynamically available for whatever tenant needs that, and for all the applications as created and instantiated by all the different VMs that exist to make that application happen. All of those apps across all of those tenants all need to have that kind of dynamic real-time access to those three fundamental services of networking, storage, and MIPS and computational power, right? For storage and for compute, generally we have that, right? And it's only with software-defined networking that we're really able to bring that to the networking plane as well. I apologize for the typo that, of course, I just catch as I'm flipping through the slide at the top. The thing that's really interesting that's going on right now is that this isn't just staying within the cloud scale data centers. This is I hate to mischaracterize it, but this really is a fundamental revolution in the way that we start to think about networking generally. And it's not just networking at the massive scale. This is networking that's now moving down into the enterprise scale as well. And so I just pulled a whole series of numbers here from a variety of different sources. You know, where the forecast of the market is looking to be somewhere in the neighborhood of 25 to $35 billion in 2018. In the next 5 years, the CAGR is 62%. You know, this doesn't happen. There just aren't that many cloud scale providers out there to drive this kind of market growth. This is dropping down market into enterprise class network infrastructure and enterprise class network architectures. Nearly all of the network security vendors are going to be supporting OpenFlow by this year, by 2014. I got this slide, or I got this stat a little bit last year. 2017, 60% of private cloud deployments will be automating the provisioning of information security, doing so using SDN. And I absolutely love this quote on the right. I'll just give you guys a chance to take it in a little bit. Fundamentally, what we're talking about here is the ability for applications to be able to dictate to the network what that app needs in order to operate optimally, right? Dictate what the network needs in order to support them. That's fundamentally what we're talking about. And that is fundamentally different from the way that we have thought about kind of packet networks generally, right? And it's fundamentally different than the way that we've been talking about Lync and packet networks for the last 5 years. You know, I've had the pleasure of doing a fantastic set of presentations around Lync in the enterprise network. And there's another Lync in the enterprise network happening here, being delivered by some of our consultants from the Lync Center of Excellence that go into a significant amount of detail around how Lync can operate with the kind of traditional networking infrastructure. And we're really, in this series of sessions about software-defined networking, we're really proposing a fundamentally different way of thinking about it. I love this slide. This is actually, every time that Pascal and I have an opportunity to present, he has this he has a slide in here, and I think it's just that this little girl playing with a tablet is just kind of perfect, right? Let's have applications and networks just play better together. And right now, boy, that's fairly tough, right? So I've gone through and I've done a fair number of these enterprise networking sessions with Lync. And one of the ways that I kind of structure the information for the audience is I base it off of the OSI layer. And I kind of talk through at every layer of OSI. You know, physical layer, let's think about raw bandwidth. Data link, let's think about VLANs. Let's think about LLDP for phones. Let's think about marking packets at the network layer. At the transport layer, let's think about your port ranges and how to configure that. If I need to be able to policy on a session basis, let's talk about the way that called mission control functions with Lync. Let's talk about the way that you can allow calls to go through one network path for audio and have another network path for video, that level of plasticity the Lync provides. Let's talk about load balancing, either with an application delivery controller or with DNS. And then, of course, with our partners, we can extend that even further with intrusion detection, with SBCs, and so forth. There's a lot of pieces here, though, right? There's a lot of work that goes into the traditional way of thinking for any UC system. This is not something that's unique with Lync, right? Which is great. One of the things that we do in helping customers move forward in their Lync deployments is we talk about how are you thinking about your network right now with real-time traffic? Do you use VLANs? Great, we'll tag VLANs. Do you mark packets? Great. Let's talk about your queues. How many levels of queuing of queues do you have in your packet network? Do you have 3? Do you have 5? Do you have 7? I think Cisco recommends 9. I've never actually seen anybody do that, but you could. One of the things that happens, though, is that complexity at the network layer actually ends up having some fairly significant impacts. Based on research that we've done, both with Lync Online and with Lync Server, we find that well over 50% of the end user quality issues, poor audio quality, my video doesn't look good, I have spotty connections, sometimes it works, sometimes it doesn't. Over 50% of that we can directly attribute to fundamental network issues. End to end, my quaz gets dropped. I'm sitting on the wrong VLAN for my phones. Somebody goes and upgrades the switch hardware. When they upgrade the switch hardware, they reflash all the routing rules onto the switch. Oh, they used the wrong version of the routing rules that were recently updated for Lync, and as a result, we lose all of that configuration. And a lot of times finding those pieces can really be a needle in a haystack. It can be really tough. The other side of things is that, by default, Lync does everything encrypted. You have to work hard to turn off the encryption for Lync. It takes a lot of effort to go and turn that off because we want all of our media traffic to be encrypted end to end, right? So a lot of times the IDS systems, the IPS systems, they don't have visibility into the media traffic that Lync is pushing. Skype's whole history, for goodness sake, has been trying to hide from network administrators, right? I mean, all the ways that Skype's media traffic has functioned on, from how it egresses, the way it works through networks, everything else has been fundamentally designed around making it to where it can work regardless of what's going on from the network administration perspective. And this, the side from a traffic engineering and quality of service perspective, it is complex, and it is brittle, and it can be broken, right? So we've got to, assign policies down on the client side. We've got to assign policies down on the server side for AVMCU and ASMCU and all the other media services that you want to tag traffic. And then you got to make sure that the network is going to honor all of these pieces, right? And anytime that you have these kind of intermittent problems or, with a 1 out of 10,000 calls has something goofy happen with it, it can be really hard to track that down. This is what we're kind of facing. This is what we're looking at today as we start scaling out enterprise UC applications, as we're scaling into the, 6 digits in a lot of our deployments for voice and video. And if we think about what's coming in the future, if we think about what's coming in the next 3 to 5 years, right, we have it really easy right now. Because in the next 3 to 5 years, we're not just going to be thinking about a set of services running in our data center. We're going to be thinking about a hybrid model. We're going to be thinking about being able to take advantage of Office 365 services that exist up in the cloud and that you can take advantage of in concurrence with capabilities that are happening on premises. We're going to be thinking about private cloud architectures that are hosted by partners And the partner that's providing you that private cloud infrastructure may be different than the partner that's providing your network infrastructure, that's providing your MPLS lines. And then you may want to have all that tied in with Office 365 as well. We're actively thinking about all of these different approaches of being able to offer cloud services to on-premises customers, right? And so the challenges that we see in the next 3 to 5 years really take this and really step it up. And so fundamentally what we need to start thinking about is a way for applications to be able to instruct the network on what they need. And this is if you really kind of look at a lot of the SDN material out there, this is on the right, the canonical diagram with a set of applications that sit up at the top layer, and they have a set of what are called northbound interfaces or northbound APIs that go and talk to that controller platform. And I mentioned the controller earlier when we were talking about OpenFlow, right? The controller, think about it as the central kind of logic platform. And that controller is taking in requests from applications saying, this is the set of services that I need. This is the prioritization that I need for these packets. This is the load balancing that I need. This is how you should think about from an IDS IPS perspective. And then uses a southbound API to go and talk to all the physical or virtual network elements, right? The controller fundamentally provides an abstracted view of the network. When we're going and we're talking to the controller, we don't actually care what's going on underneath the scenes. The controller abstracts that from us. And the controller is also managing the requests of many different applications and many different workloads simultaneously. And then when we think about this from a Lync perspective, Lync and Skype are those applications sitting at the top layer. Lync and Skype have a set of APIs that are available to go and interface with the controller and are then able to go and talk to the different network elements. If you want to kind of think about what some of the different products and different things that fit into each of these buckets, again, traditionally, that application layer has been thought of as data center applications, virtual machines. I'm going to move a VM from one data center to another. I want to be able to pick up all of the network knowledge and infrastructure and requirements of this app and be able to have it exist in my new data center. That's what traditionally we've been talking about with SDN. Now we're starting to talk about how UC can dynamically say, I have a set of requirements for this media flow. And I'm going to go now and tell the network how to prioritize this particular media flow from point A to point B and make sure that it happens optimally. When we set out on this, we were really clear that we couldn't tackle this as kind of the universe of things that SDN could provide. And so we as a team really forced ourselves to think long and hard about what are the areas that we want to focus on. And first and foremost, it was that we wanted to be able to come to market quickly, and we wanted to be able to have something tangible and real for our customers to be able to take advantage of. And so our strategy is really around 3 key scenarios. And for those of you that were here at the beginning of the session, you may notice that some of these scenarios have something to do with the sessions that are happening later on at Lync Conference. First and most important, how can we use the information coming out of the Lync SDN API to help folks diagnose what's happening in their networks? Let's be proactive and let's automate the process of finding out that needle in a haystack that caused the audio issue. Let's make sure that we can get down to the root cause of bad Lync calls very, very quickly and understand what's happening in our network. Second, Let's think about how we can provide an automated way of doing quality of service across the network. Instead of the static and rigid set of policies that exist today with DSCP and QoS, let's automate that. And let's bring that forward and say, when a flow starts up, I know that I need to have this level of service, this level of capability existing on the network. And then finally, the concept of orchestration. Let's take that quality of service capability and let's expand that to all the different devices that exist in the network. Let's expand that to all the different elements that touch the Lync media flow. And here we're thinking about our firewalls and our intrusion detection systems and our application delivery controllers and our fundamental network elements of switches, hubs, and routers. Today, we have solutions with our partners on the diagnostics front and on the QoS front. The orchestration piece is something that we're working on right now. The orchestration piece that's our kind of long-term strategy, is to think about the way that we can have all of these network elements automated in a robust manner. And that's really where we start to get excited about the capabilities for SDN and the management, operation, and facility of our own Office 365 implementations of Lync, and the hybrid implementations of Lync, and the partner implementations of Lync that work in conjunction with Office 365. Those are the elements that start to get us really excited, and that's kind of where the future of this capability and of this plan and strategy comes from. But fundamentally, where it begins is a set of investments that we've done on the Lync SDN API. And so to help take us through what that actually looks like, the methods and all the other pieces, Pascal's going to come up and he's going to take us through the details. Thank you, sir.
Appreciate it. So I thought today with Jamie, I can summarize it. The most takeaway point is that software-defined networks is not about open flow. It's not about optimizing networks to be better. It's truly about software defining the network. Truly the ability for the software, the end user applications like Lync that can actually program the network through some kind of interface, and then the networks just do the right thing. Now, I don't know about you, I've been in internet networking for almost 30 years. I've never seen something like this. So we tried to do it with RSVP, didn't really take off. As many attempts. I think with software-defined networks, it's probably a much more reality as we're seeing that happen in the data centers already. So it's really an important concept to take away, that it's about applications programming the networks. How it does it underneath is abstracted to us. We don't care. Whether it uses OpenFlow in the southbound API or uses CLI commands or uses SNMP, it's whatever's the right mechanism. So purists would say it's about OpenFlow, but I just want to make sure that people understand it's about the abstraction layer applications programming networks. So if I could just see a show of hands, how many people are end user enterprise customers? Okay, about maybe a third of the room. How many, the rest are all vendors? Show of hands, please. Yeah, quite a significant amount. Okay, great. So I'd like to talk to you about, I'll cover both. Basically on the API, we've actually released this API. It's got released actually at the Lync conference last year, and we had called it the Lync Network Diagnostic API in anticipation of actually our full program. And today we've actually announced the Lync SDN API. It got shipped on 1.0 in last conference, and now we're in 2.0. And let me take you through the major or the basic construct of what this is. So really what you have is a Lync deployment, and you have a network controller, and this could be a Wi-Fi. This doesn't have to be end-to-end. This could be just even the islands, for example, a Wi-Fi controller managing a bunch of APs. But in this case, I'll give it to you just an overview of a generic model of an SDN. So what happens basically is as the call flow starts up, the endpoint proxies the signal over to the Lync server, obviously to find where that destination lives. The front ends actually pass that signal to the actual proper destination. And then media starts to flow. Okay, so this is standard, you know, the standard SIP model that you see all the time and how things work. But as soon as that media flows, within sub-seconds, we send out an event. We send out an event. It's a web service. It's a web service API that basically is RESTful in architecture. And this is really what we call in the SDN paradigm the northbound API, one of the northbounds, the latitudes of the northbound API. I'll go into that in more details. And what's really important about this in this API is we send out that a session started, and here are some attributes about the session, including the five proper IP address, port addresses, the SIP URIs, voice video data. So there's a lot of richness of this attributes, including if it goes from starts up at voice and goes to video, we'll do an update, and then finally when the session's over, we'll end the session. So that's the first basic construct of this API. And as Jamie's alluded to, this is not a futuristic science project. This is real. It's shipping. You can download this API. You can search Lync space SDN API, and you can download it off the website for free. And I'll talk more about that. And partners are actually using that and doing some very, very innovative stuff that you'll see in the other sessions, and that's on the floor. The other thing that happens is, as soon as that event happens, the controller will program out, you know, whether it be APs or end-to-end, depending on what the solution scenario is, program out exactly for that flow in the media the right QoS settings, or making sure for IPS IDS that it doesn't try to scrub it and try to process it to cause more delay and jitter. Or for firewalls, open up, you know, the correct pinholes, things like that. So there are various scenarios, but the idea is that the event of the application programs the controller has the intelligence, the global view, and then the controller then programs where that flow is going from A to Z and programs it so that the session gets the right level of performance or the right level of requirements to what it requested. So that's really one of the basic concepts. The next basic construct is another kind of event. In this case, you have the signaling starts up, you have the media, and now there's actually a problem with the session. Something's going on with the network. It's dropping packets. Something's happening. The idea what we could do at this point is send right away, but ideally we'd like to do is send right away, you know, that there's a problem going on with the session. And so not only has the session started, but we're having a problem with the session. And specifically, we're seeing dropped packets or a MOS score very low, or you know, too much jitter, too much delay. Now the idea is that the network can take that and try to do something with that and adapt it. So now we're talking about a network not only, you know, handling the requirements, provisioning it, but also adapting itself, truly adapting itself to make sure that that flow that's having a problem can be corrected. And this is very important for us because at the end of the day, when customers have a problem with their Lync session or Skype, they blame us. And yet, as Jamie has alluded to, 60 to 80% of the problems are not us. They're coming from the network. This is being the impetus for why we want this to happen and why the industry needs this to happen. As customers out there, vendors out there, you know, you're tired of having to take those support calls and users complaining and then try to figure out what's going on. You just want the network to do the right thing, right? So as soon as that event comes out of actually the problem, again, the network, I said, adapts itself. So these are the two major constructs of the API. The API will continue to evolve, to take information from the network itself and provide intelligence into new scenarios like call admission control, and we'll get into that at the very end. But this is the two constructs today that the API ships with, and like I said, we'll add more events. So we've actually announced, like I said, Lync SDN API version 2.0. We went from 1.0, which is very basic, from a diagnostic-only scenario. 1.2 came out, and now we're actually 2.0. And the key concept of 2.0 is we introduced this new idea called an SDN manager. It's a software entity. Think of it as kind of like a role. You could actually load it anywhere. You can even load it in the front end, or you can load it on your own hardware. Its role is, in the future, will be very predominant. And we'll talk about that more, how that shows out. We also, in 2.0, have the ability of actually filtering events. so that we don't send to our partners all kinds of events they're not interested to. And we aggregate. So for example, in the case of Wi-Fi, you have, like in Microsoft, we have 200 buildings. Each building has a controller for hundreds of APs. We're not going to try to send an event to 200 different controllers, right? So we can actually send it out, to like a hub model, an aggregation model. Send it out to a certain service, and then it propagates to the right parties interested for that flow. So the other thing is that we have support now for primary and secondary redundancy. In our first version, it was very cumbersome to do redundancy, and I'll go through the details. So this is what it looks like. These are the main components of what it looks like. What we do is, as a Lync client sets up, it talks to the front ends with the SIP messages. We intercept those SIP messages on the front ends, and then we actually derive from that a session started. And you see in the red lines, that's the act from the invite. We actually go ahead and we, from the offer response, glean out all this information that's relevant, and then we send out a start event. And then likewise, if things happen, get a re-invite, we'll set up an update, and so on, and finally when the call ends. And then finally, today, at the end of a call, we'll send the quality update. That's that second event I talked about the performance. We would like to do it in real time as there's a problem happening to do it, and I'll talk about the next version. But today, unfortunately, we do it at the end of a call. But we give you all the information about the call. If it was good, bad, MOS scores, you can get all kinds of very rich information. Today, that you get from the QE database is now good parts of that are involved in this quality update. So what we did in 2.0 to get that redundancy is we have the ability that the front ends, which actually loads in this software, what we call this Lync dialog listener piece of software, very small piece of software as a stub software. It basically talks to these front ends, these Lync SDN managers, and we have two of them as primary, secondary. And what happens is it's sending out the events to it, and then that's, again, deciding on who's subscribing to these events, sending out to the right network controller partner, network controllers, whether it be Wi-Fi or for wired or IDS, IPS, whatever the scenario is. And then finally, if there's a failover, we will detect that, and we will then send out to the other secondary one. So this is a primary, secondary failover model. And then that would pick it up. So state is not preserved, meaning when we fail over, we lose state, and it goes to the secondary SDN manager. And so there's a little bit of a hiccup. In the next version coming out, this is what we're going to fix. In 2.1 coming out in the next 3 months plus, don't quote me exactly 3 months, but very close to 3 months plus, give or take a month. We're going to have this idea of an in-quality update. Now, the in-quality update will actually, during the session, when there's a problem, will actually send the event out saying there's a session problem. So this is that second construct I talked about. Session's having a problem. Yes, we're having a problem. Here's the information happening right away within seconds of the actual session having problems. So this is actually a big one, and this we call an in-call quality QoE update. We also have full load balancing. So this idea that you could actually have state and both of them running in 1+1, and they're fully running together in load balancing states for the redundancy part is very important. It uses a shared database. It could be running internally with a shared memory database or externally with a SQL, depending on big enterprises. And then finally, simplification. The idea that we don't have to, you configure all of this through one file. Today it's not a UI or GUI, it's just on a CLI kind of file, or you put it in one spot, and then it takes care and propagates to all the SDN servers and the front ends and all that kind of stuff. Today you have to actually manually go on the front ends and tell the front ends to point to the SDN manager. And so the configuration is a little more complex. But in 2.1, we'll alleviate a lot of that. And also, we're also getting more and more partner requests on what are the other features. So that will probably make it in 2.1, some parts of it. So let me just talk about this architecture. I think I just covered that. Oh, I'm sorry. Did you guys see the slide or not? I was seeing the previous speaker slide, and I go, okay. anyway, so the bottom line is that this is what it'll look like in the new architecture. Is basically you see the idea that we have this shared database and the configuration is all simplified. I don't want to. I've got a certain time to do all this, so let me see where I am. 15 more minutes. So where are we today? So basically, where we are today is basically we're shipping this. You can download it. You can download it from basically the website, like I talked about. Just search Lync space SDN API. You have to install the APIs themselves, this Lync dialog listener that if you saw on the slides, you have to install them in every front end today. And then in future versions of Lync, they will be in box shipped already. But today, it's backwards compatible for 2010, 2013. You install them on their front ends, and then you point them to the SDN manager, and the SDN manager takes care of the rest. And then finally, we're working with partners to continue to advance this. So any partners interested here that has some very cool scenarios, I'm more happy to talk to you about that. We do have a rich partner ecosystem that we're driving right now in various scenarios, in diagnostics, and quality of service, and soon this whole orchestration idea that Jamie talked about. So basically, I want to just talk about the UC SDN industry standards. Not sure if anybody's interested in how interested in this, but we see a world where we don't want to have a lock-in. We don't want, customers to have to be able to buy, certain gear just from a certain vendor just to have that lock-in. We want an open standard. We want this to mature, this vision of applications programming networks to be ubiquitous across all kinds of product lines, and hopefully across other applications than just UC. And so we're driving the standard. So let me talk a little about the standard. So basically, there are a bunch of bodies driving the standards. On the very top, about the UC side, there's the UCI Forum, Unified Communication Interoperability Forum. Anybody want to join it as a vendor, please see me about that. You can also search it on the website to join that. So this idea of an application, specifically UC programming the network, is going to be driven out of that, and I'll talk about more details about that. The northbound API, generic northbound API from the controller is being developed by the ONF. They just chartered a group, and I'll talk about that, to actually define this northbound API generically, more than just UC, to do about cloud provisioning, to do about other kind of scenarios than just UC, and that's a generic northbound API. They stayed away from it for years, but finally, I'll talk about the details about that to actually define that. The controller itself, there's a lot of open source controller software, Open Daylight being the biggest. There's Open Floodlight. There is also Open Contrail from Juniper. There's a bunch of open source controllers coming out. And the ONF is actually doing a lot of work in working through some of the protocol specifications in some of these areas. And the APIs involved, the lower level APIs involved. And then finally, the southbound API, the big one started with OpenFlow. And OpenFlow was defined initially as what openflow.org, I think, and now it's part of the ONF. So ONF is now owning that spec and continue to evolve the spec. The spec at OpenFlow was originally very, layer 2-ish and 3-ish based and kind of very simplified. It's expanding and expanding and continue to expand to handle more and more scenarios. So there's a layer 4 to 7 group to doing that, for doing network function virtualization. And so there's a lot going on here, including configuration, provisioning, and all that kind of stuff. Let me talk about who's driving what. So specifically around UC, what we're calling UC SDN, UC Software-Defined Networks. We have the UCI Forum has a technical group that is defining the actual use cases around UC SDN and a certification and interoperability program. And I'm actually the chair of that group, and I've got some co-chairs, as you can see, from various different partners. And we are actually driving the use case. Our first use case, I'll talk about that, is about to be signed off, and we're going to be sending that as part of the liaison agreement to the Open Network Foundation. The Open Network Foundation will take that and then drive that into an actual technical API. And the good news is, and I'll talk more details, is that the Open Network Foundation has a bunch of subgroups, and one of the subgroups is called an end-user app subgroup that is driven by myself as the vice chair. So in some ways, the UCI forum specifies the use case, the ONF gets those use cases, and then implements the API, and the good news is I'm part of both, so that helps. So basically, this is the liaison agreement. You can find that within our website, or the UCI forum website, or the ONF website. And really, it's about, again, working together to make this happen. UC, really important, because UC, real-time voice and video, is so highly dependent on networks to do the right things. When the networks don't do the right things, the experience is end users get a bad experience at the end of the day. Operators get called on. It's just a lose-lose for everybody if we don't get this right. So the goal is to make this happen. ONF realized this. They loved the idea that an end-user app could actually program the network, create the liaison. We did this in about October of last year. We announced it. We're committed to making this happen. I'm going to go more details. So at this point, I'm going to kind of go into two different areas, what the ONF's doing and what the UCI forum's doing around this area. And so it gives you some good overview. So if you want to participate, if you want to help drive the industry, feel free to do that. There's also, the UCI forum is creating a user group for any of the enterprise customers here that will be done at the Enterprise Connect to actually drive some of these scenarios home more and work with this user group to actually make sure we get the scenarios right. So the first thing I want to talk about is the Open Network Foundation. The Open Network Foundation is the SDN forum. They are really the SDN forum. It's called Open Networking Foundation. The thing what you see on the very top here about defining northbound interfaces, they don't actually call them APIs. APIs is not the right word. They call them northbound interfaces. It's an interface. And what you first see here is that there's not a concept of just one interface. And there are layers of latitudes of interfaces, so that there's different layers of abstraction. I'm going to go into more details of this. And what I mean by this is the layers of latitude of abstractions is that at the highest layer, you can see that application there is at the highest layer of a latitude of an interface. And then somewhere down below, there could be other kind of modules like network service modules. And they have further lower layers of latitudes of abstraction of APIs, northbound APIs, talking to controllers, doing low-level functions. And yet, from the highest layer, like you see, we don't see that. So we just give our requirements or what's going on in our sessions, and then this network service application that might be running the controller or not, and I'll show you in the slide, will then take that and then do lower levels of programming using interfaces to make things happen. So I'll get more details of that. The ONF working group, the goals are, again, to drive SDN adoption. The scope is, to make it multi-vendor, to not make it proprietary. We do not want a proprietary world of this stuff. We don't want our vendors locking customers into their proprietariness and we want an open world. So that's the key takeaway. Why now? Proliferation. We believe it's the right time to actually make this happen. There's a lot of deployments. Jamie talked about the adoption rates and where it's going in the next 5 years. This is probably a decade long. I've been pioneering technologies from MPLS to Metro Ethernet. And whatever we think it's going to be a year, it takes a while. But it does get to mass adoption, and that mass adoption, things go away. For example, I was pioneering MPLS. I was very involved with ATM and frame relay, and now ATM is pretty well gone. So it's all MPLS. So this is happening, and we're driving this rapidly. Again, this is who's involved. The 3 subgroups around the Open Network Foundation. The first one is the Northbound Interface Architecture Group. They're going to be talking about the framework, about these different latitudes of APIs, and making sure what the core APIs are reusable by what they call the use case APIs, which is, for example, UCs or use cases. They'll have specific APIs that are about use cases. But when it talks to this network service layer, it'll call common APIs. So I'll get more details. I talked about the end user app subgroup that I'm driving. And then finally, this network cloud subgroup. So the cloud subgroup is really about this, data centers and cloud orchestration and all that kind of stuff. So let me talk about the UCI forum. I got another 5 minutes. So the UCI forum, I'm going to shift now to the UCI forum, is broken up into these kind of different, in the technical group, the different kind of work items happening right now. The big one we're going after and we're going to talk about is UCSDN. There is SIP v6, by the way, that is actually almost completed as a program, the big interoperable testbed certification program about to be launched, if anybody interested, and there's other kind of technical groups going on. In the chart of the UCI forum, our goal is to actually eliminate these problems of, this perceived, where the network's causing a lot of the problems to the UC, as Jamie talked about. We've actually got a charter, and our main charter is to define the use cases and get, these use cases done. I'll talk about where we are with them. And then finally, give them over to the ONF to get those APIs defined, and then come back to us at the UCI forum and basically have an interoperability and certification program for that use case. So that's really what's going on here. So this is an interesting slide because this actually breaks apart all the things I've talked about so far in the details. And sorry if I bored you in some of these. But what you see now is some of the details here. You see the idea of a controller, an SDN controller, will take care of global views of things like path computations, inventory, topology discovery, flow programming, statistics. These are very low-level modules or very low-level functions. And they talk in southbound terms of these kind of things that they're doing. However, on the northbound side, okay, you do not want an application like UC trying to talk down to these low-level functions, because then you don't get abstraction. And this is the whole idea about SDN, extract over abstractions. What you do want is some analytical layer between the controller of this low-level, SDN controller functions that you'll see in all SDN controllers. And you want this, what I call the network service layer, network service function. And this network service function is the use case for the UCSDN. So for example, automating QoS, right, for UC would have a specific application, and you can see a demo from HP showing this, and they have a specific around automating QoS. Aruba has one also, same for Wi-Fi, automating QoS. And that's just what that network service module does. It just does that. And then you might have another one for traffic engineering, another one for diagnostics. If you go to Nectar's booth, you'll see one for just diagnostics, another one for security. And this is the actual analytical layer. Now, what you're going to see happen is today they're decomposed. They can live anywhere. They don't have to live in the controller. They can live anywhere and talk in the northbound interface to the SDN controller. And this is the latitudes of MBIs I talked about. At the highest latitude, you see the UC app just talking and giving itself to these network service apps. And then the network service apps are actually going ahead and using another lower layer of latitudes of northbound interfaces and using core APIs saying, okay, as a QoS app, I want to look at the topology of this flow. I want to know where the path is of the flow. I want to program the QoS settings. And so it's calling these core APIs up the northbound lower latitude APIs, calling them. And the cloud app, which is, I'm not sure here, could do the exact same thing and have a different use case on the use case higher layer latitude API, but yet call the same for its cloud application, have the same core APIs at the bottom. This is what we're trying to do in the ONF and the UCI forum. So in essence, what you get is basically the idea is that a controller tomorrow will actually start having these service applications, these network service applications, be part of the controller because it'll give more value to the controller. This is what you're going to start seeing appearing, is the controller and these apps are going to start merging together, and then a controller will differentiate itself about these network service functions. Okay? And finally, as you look at it, what I just described, that hierarchy, you actually, at the end of the day, what we want to do is, from an abstraction layer, UC as an application, we just want to be able to just see the network as an intelligent black box, not a ships in the night black box. Today, applications take their packets, shove them on the wire, and hope for the best. And if it doesn't work, they have this protocol called TCP to retransmit, right? That's really not what we're trying to say. In fact, most of our traffic is UDP, and so, retransmission is not real possible for real-time media. So basically, we want an intelligent black box. We want that when the UC application says a session started, the intelligent black box, whether it be global between, you're in Las Vegas going to New York or to Paris, it doesn't matter. That black box, whether it be hopefully the internet one day, is intelligent enough to just handle that and do the right thing. So that's the vision. That's what we're trying to get to. This is the use case for automating QoS. Is our first use case in UCI Forum. This is about to be signed off with the board and given to the ONF to start working on the interface. We're looking, hopefully by the end of this year, to have this interface defined as a standard. And you can actually see these demos in real life, proprietary versions of this, obviously, in the exhibition halls with Aruba and HP, and the diagnostic version of this with Nectar. And there's sessions going on throughout the week in more details of all of this stuff. So this is an actual diagram taken from the use case document from the UCI Forum. It talks about, that network service module I talked about, having policy, and then talking to the controller and doing the right, what I call the lower latitudes of the APIs will be about. So other scenarios that we want to kind of get to are basically call admission control, dynamic traffic engineering by class of service. So unlike traffic engineering where you change from the shortest path to a different path, maybe longer, this is traffic engineering where we're taking that path, but we're adjusting the class of service, the bandwidth allocated for the class of service. So EF gets a certain bandwidth, 10%. Now we can adjust it to more for video and so on. Traffic engineering for media path is actually traffic steering. So getting out of the shortest path from OSPF and BGP and all that, and actually creating its own path that might be longer but better. And so you're seeing some of these aggregated flows starting with Google's data centers, if you've been following the SDN stuff. Automated diagnostics, very powerful. A session happens, you get the report, 10% bad call. You can actually look at each bad call, and it'll tell you exactly where in the network where it's happening. And you can go to see Nectar's booth, and they'll actually show you this working. So this is very powerful stuff. Security, DDoS, IDS, IPS. The idea that a lot of attacks are coming in DDoS. The idea that we could actually tell the DDoS systems, IPS, IDS systems, this is a valid flow. Trust this flow. Do not put us through your scrubbers. Because when you go through a scrubber, you'll actually see delays, and they'll try to delay it or drop packets and all that. Very bad for UC. And since we're encrypted, they think they're being attacked sometimes because if you go from voice to video, all of a sudden you see this spike in traffic, and they can consider that sometimes an attack. So they'll put through a scrubber and try to slow down the traffic and all this stuff. It's very bad. And this is happening in cloud scale all the time. In all cloud infrastructures in public cloud, they have DDoS systems in. They're looking for how many TCP SYN resets are happening, and SYN starts and all that kind of stuff. And then UDP, how much traffic they're hitting UDP by certain behavioral kinds of loads. And then firewall orchestration, pinhole firewalling, instead of having these open holes in your firewall and so on. And then finally, Wi-Fi. You'll see that. Go to Aruba's booth. You'll see some very cool stuff, sessions on what we're doing with Wi-Fi. Wi-Fi, very problematic issue for UC, and some very innovative stuff coming out here. The takeaway from this, and Jim is going to come up next, my takeaway for you guys, this is not future. This is real. Lync is pioneering this, and Skype. We are driving this. We want to make this happen. We have to make this happen. We want to take away the complexities and the high TCOs that you guys are experiencing. We want to remove that operational cost or reduce it. We can't remove it completely, reduce it. We want the experience for Lync and Skype to be phenomenal. And this is our view of how to make that happen. Obviously, there's other things we can do in Lync and Skype as an application, feature enhancements and so on, but the dependency on the network, this is our goal. This is our vision and our passion to make that happen. So with that, I'd like to bring up Jim Jim Burton. And thank you.
Thanks, Paul. Most sessions that I ever participate in, the analyst goes first, and I'm sitting there wondering, why am I last? And I realized why. Because Jamie's stomach was growling, and I realized that I'm the person between you and lunch. So I'll make this as brief as I possibly can. Guess we could go to the next slide. The analyst perspective, that would be me. I wanted to talk to you about the perspective from 4 different viewpoints, but I think before I get started, lay a little groundwork for that. We went through a lot of material here, and that information is a bit overwhelming, I'm sure, for some. And to help go through the qualifications of how, from my viewpoint, it's going to impact each of these different categories, I think we look back at 3 different things that have been discussed. 2 kind of fall into the same thing. One is just basically the whole idea of user-defined networks. And I think that the important part of that is there is going to be big savings in these networks. They're going to be easier. They're going to be well managed. Another part of that is, from a software-defined network standpoint, is the ability for the applications to manage. And you think about how powerful that is for the application to actually communicate with the network and make intelligent decisions to make sure that it's getting what it needs to deliver that solution to the end user. The other area that was discussed, and Pascal spent quite a bit of time on it, is the API. Now, in some respects, this is a little bit separated, but it's still part of it. And the importance of this API comes from some of the things that we've already seen in following this. I've been fortunate enough to actually work with one of Microsoft's partners on this, one of their depth partners, and that was Nectar, who acquired the company that actually started a lot of this, and to observe some of the successes that they've had with leveraging this API and looking at the network to find problems. And 2 of the first stories that came out about implementations that they win showed implementations that were going to be kicked down. These implementations were not working. The value wasn't there. But by implementing this service, using the API, Nectar was able to point out that the problem was, in one case, with the carrier, and another problem was just with the fact that the network had been set up improperly and people weren't paying attention to that. So if you go to those 3 different areas that I just talked about, SDN and the API, and SDN and how the application to manage it, I'll go through each of these categories to discuss how I think the impact is going to be. First of all, on the enterprise customer, the good news is a lot of improvements. Cost is going to go down, and the service and what's required is going to be less. So from a budgeting standpoint, there will be money saved on the overall cost and the management it's going to take to manage the network as it's been in the past. The services that go along with that, the API that's going to deliver services that you can monitor your network and make sure that it's working perfectly all the time, find out the problems as they happen, not after they've happened, and that's going to be a big impact. Channel partners. Are there some channel partners in the room? I know there's a bunch here. A few of you guys. This is, I think, a big thing for you because where some of you have, and I know a lot of channel partners, kind of defer to another channel partner to handle some of their networking needs. As I've talked to channel partners recently about what's the possibilities with SDN, they realize that they can now get into the game. They don't have that big iron that they have to start selling, that they can deliver these services. They also recognize, because of the API, that they're going to be able to go in before an implementation, make sure it's working properly, and monitor the implementation after. So everything works really, really well. So the vendors, the next, and I'm buzzing through these things because I know I hear your stomachs growling. The vendors is another interesting area, and this comes in, say, 2 or 3 categories. The vendors who've been providing network services, and we can use Cisco as that example, they're looking at their revenue being crunched dramatically because of SDN. I've heard numbers like $8 billion of market cap will be lost because of SDN to Cisco. That's a big, big number. Whether that number is exactly right or not, I don't know. I've heard some people say it's even higher than that. So clearly there's going to be an impact on that particular vendor. Other vendors who are going to jump into this opportunity, like Microsoft, are going to do well, and HP. And I've heard the numbers, and HP has told me not to tell you, the number of HP SDN deployments is enormous. This isn't in a pilot stage now. I'm convinced now it's not. So some vendors are going to do very well. And then there are other vendors who are developing the applications. And the opportunity for you to make sure your application gets what it needs from the network is going to be extremely powerful. The last group is consultants. And while there aren't many consultants in the room, if any, I think it's important to talk about it because consultants who come in to help enterprise customers make decisions, they're all faced with the challenge of how do I make sure that this implementation goes right? That's why they're paying me for this. That's why it's important. A lot of consultants do hire network experts to help come in and do some of these things. But with an opportunity to take software that is using the API to go in and look at that network before an implementation, all of a sudden it becomes very, very successful. One of the things that I've recommended to Nectar, doesn't mean that they'll take that advice, but one thing I've recommended is that they offer a very, very cost-effective way for a consultant to get their hands on that software, go in and do an analysis before the implementation to make sure everything's right so you've got a flawless implementation. So that ends up coming back to helping customers, helping the channel partners, certainly the vendors whose projects they're working on. That's exactly what you really want to do with all of this. So kind of getting back to what Pascal said he wants you to walk away with. It's really important. It's a new day, and what Gurdeep had to say. We're getting ready to embark on a whole new area of how this industry is evolving. And it's very different. I mean, UC got us to a certain point, but the things we're looking at going into the future, having the ability to have SDN, to have the API that can help figure out where the problems are, it is going to be so important and so powerful going forward that this is the future. Pascal's also right. It's going to take a little longer than we'd all like to think, but we've got to start. We've all got to work together. Do many of you come to Enterprise Connect? A couple of you. Michael, you're going to be there. You're going to be there this year. Good. One of the things that we're working, UC Strategies, who I'm affiliated with, is working on with the UCI Forum is to have a little gathering. We have a wine tasting that I'll make sure if you let Pascal know, he'll see that you get invitations to come to this wine tasting. It's a gathering of chance for us like-minded people to get together and talk about the services, the technology, and how you may be able to participate in the UCI Forum to help make these things just happen a little bit faster. So with that, I will turn it back to these gentlemen for questions.
Thank you so much.
Now,
Appreciate it, Jim. And yeah, I just wanted to. I've got a mic. I'm good. Appreciate it. No, I just want to reiterate one more thing. Like again, it's here and it's happening, and we have to do this for our own cloud, for our ability to be able to execute effectively. That one in Office 365. We have to have this functionality. We have to have this capability up and running. We have to be thinking about our networks and our infrastructure and SDN paradigm. That's necessary for us to be able to deliver Office 365 in a scalable, resilient, robust manner. And there's just no other way for us to think about that. And so, like I said, we've got 3 other sessions that are happening in the network track that will go into more detail with diagnostics, with Nectar, with Wi-Fi and Aruba, and Quaz with HP. Make sure if you have interest in any of those domains to please go and check out those sessions. They're happening both today and tomorrow. And I don't know why the slides are automatically advancing again, but they are. This is the first session slot of Lync Conference. I thank you so much for joining us during this. Know you have lots and lots of opportunities for lots of different types of content here at the conference. And so just thank you all for coming out. There's tons more that's happening throughout this week, not just on SDM, but on all sorts of different domains of the product. So please take full advantage of it, and Pascal and I will be available for questions as we walk out. Lunch will be, as I'm sure you all are stomachs growling, lunch will be in the newly turned keynote room. As we've been hanging out here, folks have been busily turning all of those chairs into places for us to eat. So head on back to the keynote room, and it'll be all completely different now. So thank you so much for your time.